Rather than doing some sample problems with this learning objective of classifying small organic molecules as polar or nonpolar, I'm going to walk through an activity where you just take any functional group and you say, okay, would this functional group make a molecule polar or nonpolar? So you can do that now. You can pull out your quick reference sheet with its list of functional groups and just classify them. Would this be polar or nonpolar? So alkanes are often the first one. Anything that just has carbon bonded to hydrogen is going to be nonpolar. So something like that, nonpolar. Go to the next one, alkene. Same situation. Also nonpolar. Alkyne. Here we see straight. A straight shape at this central atom. Also nonpolar. How about alkyl halides? Well, they have C bonded to a halide. So usually they're going to be polar. There are some exceptions. Teflon is long carbon chains completely surrounded by fluorine. So I'll write that over here, something like then you have all this symmetry where on the outside all these F's pull electrons toward them, but they all pull them the same amount. So a completely halogenated alkane is going to be nonpolar. So there's an exception. Let's go to the next. Arenes. Like benzene. Just carbon and hydrogen. They've got double bonds, so they're electron rich. That's something that will become relevant with reactions. Alkynes and arenes are electron rich, but they are nonpolar. Alcohols, they've got C bonded to O. They're going to be polar. Thiols, they're a little iffy. I'll put them in the middle, but no, I'm going to put them here. Thiols, sulfides, disulfide, a thiol might be a tiny bit polar. Sulfide, really not polar. Disulfide, not polar. Ethers, they've got C bonded to O. But they've got C's on each side. So it's only weakly polar. This is a pretty weakly polar molecule. Let's go to aldehydes and ketones. There's our CO bond. It's quite polar. Turns out ketones often have a stronger dipole than aldehydes. So both of these are polar. Let's move on to carboxylic acids. Just drawing acetic acid here. You can see the O's are going to be quite negative, the H a bit positive, the C here a bit positive, so it's a polar molecule. Other things similar to carboxylic acids. Esters. Definitely polar, but with extra carbon here, that makes it a little bit less polar. Amides. You can see this has NHs, and you may remember the NHs can hydrogen bond. This is quite a polar group. Amines. An amine, when it has two H's and a carbon, that's quite polar. Let's put an exception. If on an amine or an amide, we attach extra carbons, it makes them less polar. This triethylamine is not going to be very polar at all. And you could do this with any other functional group that you look at. Look and see what's bonded to the carbon. Is it something like hydrogen or sulfur, or is it nitrogen or oxygen or a halogen? This is usually going to give you polar. This will never give you polar. This will always be nonpolar. And we're going to save this sheet as a reference for our next set of problems.